Hi everyone, today we're working on lesson 2. We are going to convert from standard form to vertex form through this process we call completing the square. Now this kind of has a lot to it, so make sure that you are understanding. If not, watch the video again. You can also Google search completing the square, lots of practice comes up. This is a concept that's not going to go away and you're going to see it in later on math classes, so it's very important that you understand it. If not, you can always contact me as well, and we can go over it one-on-one or during a Zoom session. All right, let's get started on our notes. And I'm starting from the Learning from Home folder on Schoology, going to the week of May 4th. We are on the Tuesday lesson, lesson 2 today. Clicking on our notes for today. Today we're working on standard form to vertex form. Our learning target is I can convert a quadratic in standard form to vertex form by completing the square. So this is a very big concept, and like I mentioned before, it is not going away. So please make sure if you are confused about anything, let me know. So it says, how can we take a quadratic of the form y equals ax squared plus bx plus c and put it into vertex form? Vertex form looks like this. So it's just a rearranged version of the same quadratic, just in a different form. It just looks different, okay? We call it vertex form because we can identify the vertex just by looking at the equation. We're not going to get there for today, but that's another purpose of completing the square. So in order to get something into vertex form, so if a question says, convert this quadratic into vertex form, you are going to do a process called completing the square. It will help to first identify A, B, and C terms. Remember, the A term is always attached to x squared, B term is attached to the x, and C is the constant. Okay, you can see that identified here in the standard form of the quadratic up at the top. So let's just look at an example. It's already worked out for us. So it says, convert the following quadratic from standard form to vertex form by completing the square. So this is our standard form quadratic. First step, identify A, B, and C. A is always the one attached to x squared. That coefficient of that x squared is a 1. It's just not inputted in there. B is 6, and the constant is 2. You can see that identified right down here. Okay? So your next step, now the steps, they didn't consider that a step, but I guess we'll just go off of their notes here. This is an image I found on Google. So it says step 1, divide the B value by 2. My B value I identified as 6, so I'm going to divide that by 2 and I get 3. My second step is to square whatever we got in step 1. So we got 3 in step 1. So we square that, and now we have 9. So then what you're going to do, you're going to add and subtract 9 between the B and the C values of the trinomial. The reason we do that is because right now we are kind of just playing around with the equation, but we can't change the equation. So if we add 9 to the equation, we changed it. So therefore we have to subtract it as well to keep it balanced so that it really didn't change the equation at all. So you're going to write it between the B and C terms, okay? So your constant should still come at the end. Then you're going to place parentheses around the first 3 terms, okay? So it looks like so it's a trinomial that you're putting parentheses around. This is what we call a perfect square trinomial. I'll explain that in a second. If we factor this, let me get out my pen here. So if we factor this trinomial right here, okay, GCF is a no-go, dots is a no-go. We're going to do basic trinomial factoring. And this type of factoring is going to look the same for every single time that you complete the square. So we're looking at factors of 9 that add to 6. We double bubble. We're going to have the same signs. And guess what? Completing the square is always going to be the same signs. It's either going to be a plus plus or a minus minus. We look over here to tell us what it is. It's going to be a plus plus. Sorry for my messy handwriting here. Factors of 9 that add to 6 are 3 and 3. So you can see these numbers in here are always going to be the same when you complete the square, because do you see how they rewrote it? They rewrote it as x plus 3 squared, which is what that is. Now, if you're wondering where this -7 came from, remember we still had the -9 and then the constant. We just simplify that. -9 plus 2 gives me -7. All right, let's try some examples here. So this is really broken down for us. And it really looks like I forgot to write the actual problem in this Google Doc, so I'm just going to pause it for a second and put it in there. Okay, there it is, like it was always there. It will be there by the time you get to these notes. So we're going to first identify A, B, and C values. The A value, again, always in front of the x squared. For this one, it's 1. Our B value is 4, and our C value is 3. Okay, our next step is to take your B term and divide it by 2. My B term is 4, so I'm going to do 4 divided by 2, which gives me 2. Next step, square your answer. So 2 squared, 2 times 2 gives me 4. Then you are going to add that number and subtract that number between the B and C values. So I already have the plus and the minus in here for you. So you just need to do add 4, and then we are subtracting 4. You can see I split it for you. Here's my my A and B terms, and my C term is over here. So we're putting it right in between B and C. The reason we do that is because our next step is to group the first 3 terms to make a trinomial. Again, we call this a perfect square trinomial. And then we still have the -4 and the +3 on the outside that we'll simplify in a minute. So we then put those parentheses around it. And now we're going to factor the trinomial in parentheses and simplify the numbers outside the parentheses. And that is spelled incorrectly. Okay, so we are going to find factors of 4 that add to 4. Again, we double bubble, I already set that up for you. We're going to have the same signs, as it is always going to be the same signs for completing the square. We look at this operator as a plus to tell us what signs they're going to be. So it's going to be a plus and a plus. Oops. Need to go back. There we go. All right, so now factors of 4 that add to 4 are 2 and 2. I don't know why this is being so weird. Probably because it's a Google Doc, so everything's kind of a little funky. Okay. 2? No. I'm going to pause this while I figure this out. Okay, I sort of figured it out. It just doesn't look pretty, but we got x plus 2 and x plus 2, and you can see this was already simplified for you. -4 plus 3 gives us that -1. Now we rewrite it as x plus 2. Okay, I might fix this for you guys before you have to go into it, because this is a little much. So x plus, and now it's bold. X plus 2 squared, that's why it's called a perfect square trinomial, -1. Now, just for future reference, if we were to tell you what the vertex is, the vertex is -2, -1. It's always the opposite of what's inside. And then on the outside, it's exactly what it looks like, okay? You don't need to know that right at this time, so I'm gonna erase that, but just for those of you who wanna get a step ahead. All right, so number 2 is same type of problem. I really want you to refer back to this example number 1 that we did together, and I want you to try to do it on your own. So pause the video and give it a try. All right, so I'm going to walk you through my work. My first step, I identified A, B, and C. My second step, I took my B term and divided it by 2 and got -5. My third step, I squared what I got. So -5 squared gives me a positive 25. It should always be positive when you square it, when you complete the square. And then I plugged it in. So I added 25 to my equation and I subtracted 25 to my equation. Okay, I kind of combined these steps because then I also put parentheses around those first 3 terms to make my perfect square trinomial. Then when I factored it, I knew I did forget. I mean, I didn't really do the initial step. I'll add that in. So I didn't double bubble because after you get used to this, you'll know how to go right from here, step 4 to step 6. Okay, but factors of 25 that add to 10, but keep in mind, it's the same signs like it always is, but this one is a minus. So we're gonna have x minus, and then x minus, and then negative 25 plus 9 gives me negative 16. And factors of 25 that add to 10 are 5 and 5. And hopefully you can see how that converts to the Vertex form below. Okay? All right, so numbers 3 and 4, I really want you trying on your own. Okay, so I did 2 examples with you. I want you to really refer back to these steps up here. Okay? And then, so pause the video and then you can come back to see the answers. All right, let's check our work. Here's number 3. Okay, you can see our vertex form for number 3 doesn't have a constant at the end, and that can happen sometimes. That's still in vertex form. And number 4, there's our answer right there. And that's all we got for completing the square. You will need to know how to do this for tomorrow's lesson. So again, questions or concerns, let me know in your self-assessment or you can contact me. So again, speaking of your self-assessment, make sure you go back. In today's plan, there's a link for the self-assessment, or you can also find it in the weekly folder right at the top where it says week of 5, or no, where it says week of 5 for self-assessment right here. All right, we'll see you during the next lesson.